workshop is going to be based on. With disease risk analysis, as with many other things, there are many ways to skin a cat or skin a pig. And this is just one method that is being used specifically for wildlife, but it can be used across for domestics as well. But the process follows the same sort of process as for other ways to do a risk analysis. I'd just like to introduce you to, who unfortunately is not here, but Dr. Felicia Nutter. We started work in Indonesia through the Indonesian University One Health Network on this for looking at issues of disease between humans, orangutans, and gibbons. So that was sort of more looking at a more zoonotic thing, but Felicia helped, right? Oh, okay, first technical issue of the day, is it's not forward, okay, right. So also to show that disease risk analysis is best done as part of a group. It's been mentioned to sort of say that it's better not to have, you can do a DRA on your own, but by doing it together collectively in that interdisciplinary way, you're less likely to have bias. It does take longer, but you're going to get all the relevant people to be heard. So thank you to these colleagues for generously sharing their materials and expertise. We as humans are not very good, if left to our own devices, at looking at what the world is actually telling us. So it was mentioned before about COVID-19. Thank you for that segue, Dirk. I agree. From little I know about what ASF is doing, it is similar to COVID-19 in how we are approaching it. The only difference is, of course, is we as humans, thankfully, cannot get African swine fever, so it's not a zoonotic infection. But the general human response to something like COVID-19 is what's been put there in there. And we're looking at this as a systems approach, and how we can take a step back and how we can look at what are the things that are actually going to be causing problems for us on a systems level. And so with ASF, that's between domestic and wildlife. So the panel discussion was fantastic because it highlighted that idea that to be able to solve this challenge, we need to look at that big picture ecosystem view. Because my dulcet tones might send you to sleep, I usually start with the conclusions of any talk. So why do we even consider using this as a potential tool? Well, the first reason, as I said in that first slide, is often we need help, other tools to help us just as the human animal to be able to see the situation as it is. It's already been mentioned that ASF is a really complex situation. And also that in wildlife disease in general, at least, there's often big data gaps. We often don't know. And as humans, we don't like uncertainty. We would like to have a plan. This is what we're going to do, and this is how we think. So a DRA combines that complex data, the complexity of the situation with data deficiency associated with wildlife disease into with that high level of uncertainty to be able to estimate that risk. Now, this can be reduced, and I'm going to talk a little bit about One Health, and certainly referring to what Dirk said about the geopolitical, socioeconomic foundations of that. And the DRA is just a tool in the toolkit that we can use to help share that data. Now, most importantly, it's also being transparent in how we approach things. And also it says at the very beginning, as you'll see in the workbook, what assumptions we're making, and most importantly, what are the limitations of the process we're doing to be able to refine that as we go. So the manual was designed as a go-to resource for those who are specifically working with wildlife, but also at the human-domestic wildlife interface. And so the audience for this is not so much veterinarians, but people who are decision makers or management who are trying to fix the situation, which of course does include vets, but it's not a veterinary document per se. See, there's a little bit of a delay as it goes around the world when I try to go to the next slide. Or you can just look at the conclusions for the rest of the day. There we go. All right,
Okay.
sorry. So it's okay. Right. So okay, no, we're good. We're back in control. So like any new process, there is a range of different jargon, which the whole idea of this process is to be able to try and avoid that. But unfortunately, there are some that we cannot avoid, and that is actually what the different components of the process is. And that can be broken down basically just to a series of questions. What can go wrong? Now, with this hazard identification, we're dealing with one particular infectious disease agent, African swine fever, or the virus that causes African swine fever. But I'll introduce some other sort of things that may feed into that as well. So that what can go wrong? You can have ASF. How can it go wrong? That's what we're looking at this afternoon in the next part of the section. That's what's called a pathway analysis. How likely is it to go wrong? That's the risk assessment itself, which we'll be doing going through tomorrow morning. Sorry, for my time, the first session for you tomorrow. What can we do to control or prevent this potential bad thing? That's the management process. We'll start on that tomorrow and then work on that into day 3. And what I think needs to be the very first bit, who needs to know? And this, as we've been sort of saying this today, is that by not having good communication between the people who need to know, the stakeholders in the situation, that is often where situations can go wrong. Because it's so important to communicate in the right way, at the right time, clearly and accurately. So one of the tasks we're going to be getting you to do tomorrow is being able to map those communications pathways as to what's needed for the situation. And it's good that we've sort of discussed about the geopolitical boundaries. Again, with COVID-19, as we've seen in various parts of the world, SARS-CoV-2 doesn't care if you're a Democrat or a Republican, not to pick on our American colleagues, or it doesn't care if you live in England or if you live in Germany or if you live in Indonesia or if you live in the Philippines. It's just trying to find a place to replicate. So for ASF, as far as the virus is concerned, what seems to be the case, a pig is a pig. Yes, there's going to be different susceptibilities between species, but that's why we need to make sure that we take the system approach as a whole. And so that brings me to, with disease risk analysis as a whole, but specifically wildlife disease risk analysis resides within this concept of One Health. And I think I'm going to show you 3 different ways of how One Health has been shown over the last years. This is more of a medical sort of version from our colleagues in Sweden. But the basic concept, as I'm sure you're aware, is the interactions between the environment, non-human animals, and human health. And in the case of ASF, I would put that actually down to the side of food security. So it's not just talking about how we obviously don't actually get the virus itself, but making sure that those different aspects are interacted. So here it's just shown as between individual population and ecosystem. Another one that was proposed back in the mid-2010s, and this also brings into focus what Dirk was saying as well, is I'm a veterinarian, many of the participants here are veterinarians. We are mostly dealing in this top area here, emergency medicine and preventive medicine, because we're using the avian influenza example, we want to stop the death of chickens and people, and we want to be able to try and prevent that in ways that we know how. However, in these sorts of situations that are multi-species and within the wider environment, this concept of structural One Health, where you're looking at social, economic, and when I say social drivers there, that includes the political. If we don't focus as a group of stakeholders on what that actually means in our own sort of situation, we are never going to be able to cover the upper one. So as crisis management, if you don't account for this idea of what are the non-disease drivers, that's going to be unsustainable to be able to manage. And just this last one as well, we sort of look here as sort of as ecosystem, human and animal. There's been an update on this actually just in the last couple of months, but the authors here were looking at where has this information been published and in what sort of factors and that sort of thing. So this actually shows you when we're dealing with systems level One Health approach situations that the topics and interactions between different sectors are vitally important to be able to confirm that we're actually managing the situation correctly. So all three of these show a slightly different view of a system-wide, and you can also include that cartoon at the beginning, of to be able to manage these situations properly, taking a systems-wide approach is really important. This slide, and this is calls for audience participation time, if anyone wants to stick up their hand, and has been mentioned so far before, is when we're looking at multi-species. And I just realized I misspelled species, I do apologize. English is my second language. Multi-species disease emergence, and by what I mean by multi-species is infections that cause disease in many different species. Does anybody want to hazard a guess what might be the common denominator in these ones I've used here? I can't see any. Wildlife. Okay. Okay. Yes, that's okay. Does anyone else want to have a hazard a guess as to what all of these are sort of what the common thread to these is? These are, should I say? That was a good call on the what? They are all zoonoses. I apologize for that. That is also correct. Something that sort of think about how diseases spread between species. Okay, all right. So both of those answers were correct. But what we're actually looking for is actually, sorry, more technical issues. I think it has to go around the world before it changes. Come on, sweetie. There we go. Right. And I put that with a question mark because there are other reasons for this. Okay, so it could be argued, however, on this case, hi, sorry, that was for sound. This could be argued that for HIV-1 virus to evolve with humans, then that's somewhere along the line there was consumption of infected chimpanzee meat. Bat rabies, deforestation, farming, importation, wildlife trade versus illegal versus legal. We'd always talk about the illegal wildlife trade. The legal wildlife trade also needs to sort of be mentioned there as well as the potential. So getting here is a human behavior. So the idea of wildlife disease risk analysis specifically within the DRA field is understanding that the reason we need tools like this is to provide context to how we as humans behave and approach things. One last little contextual sort of thing is this situation of this idea of what we call disease ecology, and I'm sure the epidemiologists amongst you will understand this. From this diagram, hopefully shows you that nothing is outside the natural environment. Humans and human activity and what we produce, we are natural beings. So we have altered the environment. So what this happens here, the human landscape is totally within the natural environment. The only problem is, or potential, is that humans have modified, depending on country, but approximately 75 to 80% of the terrestrial landscape. So that means the human landscape dominates the natural environment. And we'll go into this a little bit more when we're talking about where actually wild pigs are in the next quick talk. So what this sort of talks about here, and you can read for yourselves in the guidance docs on the for the manual of wildlife disease risk analysis, is these things around the outside are examples, and I know chytrid fungus has already been mentioned as well. And the reason we are seeing this big interplay is partly because, or largely because, a large part of the natural environment is dominated by human activity. So the opportunities for spread between human and non-human animal activities and individuals is increased. So when we talk about the natural environment, that is everything. Now, also, I want to be clear on what actually risk means. So when we talk of wildlife disease risk analysis, what do we mean by risk? Basically, it's the likelihood of something happening multiplied by the consequences or severity of that occurrence happening. Now, we're going to come back to this situation here on the right when we talk about risk management. You really need to get onto that blue sky aviation plane. You do what's called a dynamic risk assessment in your brain, and you figure out whether that is a risk you are willing to take or how you can actually manage that in future. The other thing, again, just is that we are often not very good at assessing risk ourselves as a species. So this is just a bit of a joke sign, is that obviously the bridge is out ahead. That's a major problem. But like that first slide showed on COVID-19 response, compared to what else is going on within the system, we need assistance to be able to assess risk effectively. And that's where risk analyses come in. A very human example of this, and I know there is no vaccine yet for African swine fever, and this data comes from before COVID-19, but I think it helps, the idea of looking at this helps informs what current attitudes are, is you can see here that they did a European study, the EU did a European study back in 2018, with the statement, overall, I think vaccines are safe. Now, for whatever reason, and the report goes into different social cultural things, so this is why it's very important to understand that every country is different, and how we approach these things when it comes to communication means, and I'm sorry, Anne, because France didn't come out very well on this, but and it's the same with Ferran. I do apologize, you only work in France. So it's interesting to delve into how the messaging is important, and this is specifically in something that is affecting human health. So then how do we manage that where it's going to be affecting food security, it's going to be affecting biodiversity with potential species reductions and all of the woes that brings, and trying to figure out how we can approach that messaging. So this is talking specifically to the risk communication idea of what we're talking about tomorrow. So what could be for this particular thing is infectious diseases, COVID-19, the pathogen SARS-CoV-2, smallpox, polio, they inflict terrible horrors on the population. ASF wipes out 50% of the domestic pig population, and that destroys people's livelihoods. That means that you can't get your favorite pork products, and also has a potential effect on the conservation of wild species. Then vaccines are invented, which is hopefully where we're going with ASF, although I know from the team at Pearbright it's proven quite tricky. And then that makes the population safe and healthy. Okay, and so everything is good. ASF was a disease from the past. Influenza was a disease from the past. SARS-CoV-1 SARS-CoV was a disease from the past, and the population never sees the horrors of what these infectious diseases can do. It moves out of the zeitgeist. That's the only German word I know. And so populations start to think that vaccines specifically in this particular situation are not needed, and they might be considered unsafe due to misinformation or information that comes out before all of the data has been assessed. And then with that, horrible disease and death comes back with a vengeance. And this is because uncertainty makes us anxious. At the beginning of this workshop, I woke up at 3 o'clock this morning because I was afraid that nobody would show up. And then I sort of went through, okay, what is the likelihood of that? What is the likelihood of nobody showing up? We're going to record it. They can see it afterwards. What are the consequences of that? And so it's actually doing what's called a dynamic risk assessment in your head. So it's a tool to provide us evidence for decision-making under uncertainty. And in a complex situation like ASF, there is a lot of uncertainty. So because I'm living in the UK, there we go. So what does a DRA, disease risk analysis, basically do? It's science-based. So we use the evidence that we have to be able to help answer the questions. It allows us for succession planning. So no single person has control over it. So it means that if we only start the process, then that can be taken on by others. And that's partly because it promotes good communication, between all parties. Probably the most important situation for us is for these 3 days, it's going to highlight the data gaps. It's already been mentioned that we have very little quantitative information for what's going on in the wildlife populations, but also for the planners, by doing it this way, by being able to focus on what is actually needed, it provides a good cost-benefit basis. Now, the IUCN view of how to do a risk analysis is here. So the risk communication in the middle, and because we understand that it is vitally important for all the other parts. For the vets among you, I have put the SOAP format around the outside, because the way this helps us think is you start with subjective information. So you take a history. What is the problem? What are we going to be looking at? And then that helps us identify what any hazards could potentially be. Then we start through the risk assessment process, objectively gathering information. That's when we're doing diagnostics. And what are the results telling you? Then we move into how we manage the situation. So there's planning and implementation and review. And then does that change your problem description? Because I'm sorry, folks, once you've done a risk analysis and you've gone through the process, you've run it, it's iterative. You then do it again, because there's still going to be a problem. The part of the problem from before might be solved, but we are kind of used to doing that, certainly clinically, but also in our own brains. Has the risk of these hazards changed? So therefore, has the problem changed? So this is just introducing you to the process of how we can do that. So within disease risk analysis tools, we are going to be using this thing, which is called a pen and paper, and which is a worksheet, or actually, a Word document and typing. So within the manual, the IUCN manual itself, it has all these different qualitative and quantitative tools, but the good old pen and paper and worksheet is the one thing, as you can see there, that can go through each different session and each different section. Risk communication, which we'll be doing tomorrow afternoon, that's slightly different, but we can embed that into the worksheet. And just to draw your attention here to number 4, the DRA worksheet, it's the downside is it's qualitative or only semi-quantitative, so it's not so good for providing figures. But just to moderate expectations, for these 3 days, we are all participants. The next stage, if you want to go and become quantitative, become a modeler, and then become a facilitator, that's for other possibilities, for other follow-on workshops or whatever. But we can do the problem description, the hazard identification, the risk assessment, the risk management, and the risk communication, all with a worksheet. We need little technical expertise, and it's cheap, and it can be very effective. So I'm just going to use 2 quick examples here. I am on time for an interview, so that's good. So I'm going to look primarily at how does DRA has either worked or could have been used in other situations, and we'll be using different examples as we go through the next few days as well. So I'm going to concentrate firstly on human-wildlife interactions and then livestock-wildlife interactions. And we're going to look at the results of introduction of the disease, and what we need to consider in the DRA is the individual, population, and then ecosystem effect. Okay. Sorry, guys. I'm in a developing country, and it looks like my internet's playing silly buggers.
So while Steve is on hiatus, just kidding. We'll send the document in Word format. It's now in your chat box.
Okay, I'm just going to stop sharing just for a second, and just bear with. Okay, so those human-wildlife interactions, this is particularly a zoonotic infection as an example, but you can, within the case of ASF, you could consider human activity as a result of this. So this example specifically looks at two viruses, the human metapneumovirus and the respiratory syncytial virus, that was confirmed spread from the researchers who are observing these chimpanzees in the Thai forest, which is in Côte d'Ivoire, the Ivory Coast, and proof that these viruses were killing the chimpanzees and certainly and also making them very sick from these human-originated resources. Now, this is a story of risk communication as to how the transboundary issue that Sen was talking about before, how this can inform other things. So that was published in scientific report. That was then picked up by various news outlets around the world. So it says tourist bugs threaten to wipe out endangered apes. And I took this photograph in an eco lodge in a part of Indonesia. We visited and then you can see here, this messaging was followed up that this is a potential disease risk for orangutans in particular, and this was in the National Park Warden's office. And then what happened in reality at this time was you have this sort of distances. Most of these foreign tourists, because I asked them, were off the plane less than 24 hours before this photograph was taken.
Sorry,
Sorry,
we cannot see your screen actually.
You're not sharing your screen.
Sorry.
I do apologize. That's probably why it was working.
No worries.
Hold on. Thank you.
Thanks.
Thank you for telling me that, because I would have obviously burbled on. Right.
Yeah.
Okay, right. All right. So hopefully I painted a bit of a picture from the previous slides, in that you had that communication from scientific literature to media to Eco-Lodge where these people were staying. And obviously that didn't communicate effectively because this was the situation. International tourists, many from the same countries where that those original viruses came from. This situation has now been resolved, thankfully. This individual orangutan is no longer in this area either. But again, that's the important understanding of when we're looking at risk communication and something like ASF, to understand the differences between the issues of how we communicate and what the audience is going to be. And finally, this is an example from that has been risk assessed now through colleagues down in London through the IVC and Zoological Society of London. But this is a situation where the unforeseen consequences occurred in India, where this pain relief used in cattle in India or around the world, diclofenac, caused secondary toxicity in the wild vultures, because they were feeding on the cattle carcasses, so you get toxin, they get diphenolate going into the vultures. That caused, in some areas, a 99% die-off. And then from a systems level, what other species could potentially fill that ecological niche? And unfortunately, in many areas, it turned out to be feral dogs, and therefore, and they carried rabies. And so therefore, what a DRA can help sort of track and sort of fill the data gaps on is how can then, to be able to look at what we need to manage, is how pain relief for cattle increase the risk of people with rabies. This other example, I will, for time purposes, I'll go a little bit more quickly because obviously we've had a few technical issues, so it's sort of gone a little bit longer. But for those of you who are interested, to look up Hendra virus, bats, horses, Australia. And this is looking how basically Hendra virus is endemic and circulating in bats. The changing landscape, especially in Queensland and northern New South Wales in Australia, where clear felling remains the norm, brought bats into more close contact with horses. Hendra virus then killed horses, then vets did postmortems on the horses that died from Hendra virus, and that killed some vets as well. So this is looking at how land use change altered the epidemiology of a virus that was within that One Health sort of structure. So just in summary, a risk analysis starts with us asking a question, and it needs to be specific enough to address with the available resources. And that question has been posed, although we have a set of questions that have been posed in the workbook. Now, although we only have ASF as a hazard that's related to your question, that will come about how we can prioritize these sort of in different situations. What we're going to be doing this afternoon or in the next session is part 3 is drawing a picture of that system and identify critical control points, and I'll discuss those in just a moment. Then it won't be a mathematical model, but develop a model that identifies for each different situation and scenario where we have being able to evaluate the data sources where we might need to identify data gaps and where we need to input data. And then as far as the model is concerned, that's looking at that's how we go through, we're going to be doing tomorrow as part of the assessment. And so on paper or typing, we're going to be assessing the different parts of the possibility of hazard getting into the system. Then we can figure out how uncertain we are about those assumptions that we've made. And then we might need to say we need to collect more data, which we won't be doing in this session, but it highlights those different data gaps, and then rerun that model as I mentioned, as being an iterative process. Some of the previous reports used between wildlife, domestic, and humans and species are there through the CPSG website, and these are also linked to in the workbook, so you don't need to take these down immediately. I'm sure there's going to be many questions on that. If I could please just hold that for time until we do the next session,